Hi all, this is Mr. Yeager for chemistry, and we are now looking at percent composition, okay? Percent composition of compounds, all right? To do this, we need to find molar masses, okay? I know it's saying percent mass there, but we're using molar masses to figure out the percent of basically how much each element is making up the total compound, again, based on molar mass. So our equation will be the percent of the percent composition of an element will be the molar mass of that element. The total molar mass, even if there's more than one, you'll see in a moment, we'll include all of that, divided by the total molar mass of the compound itself. So really this is more about just adding up and finding molar mass than anything else. We actually get away from conversions for a moment. And it's more just, it's a little bit of a tedious task to go through, but nothing too difficult, again, in relation to trying to do conversions. Okay? Oops, sorry. So why should I care? Well, you should care because I said so. No, because we have, obviously, if we ever develop a new compound, or if I'm trying to reverse engineer a compound, okay, from another, possibly from another company, to figure out what they're doing and trying to maybe we can make it better in some ways, because once I change it a little bit, that's something I can technically patent. So we can check, obviously, what a compound is made up of and figure out its percent composition, and this is how we can determine the possible chemical formula for it. Obviously, it could be used for figuring out pollutants in the environment and things like that. It's a good first way of helping us figure out what possibly is out there, which then could lead us to where is it coming from, or we can make something new. Okay? So we're going to jump straight into it, okay? How do we do these problems? Did I hit the next one? I did. All right? So basically we have a couple steps here, okay? The way I would work through this is, 1, find the molar mass of the compound, okay? Of the compound itself. So I would do on this, again, using a periodic table, we would go carbon, there's 2 of them, times its molar mass, 12.01, plus 6 hydrogens times, sorry, I'm making sure I use the actual correct one, 1.01. Okay, again, using the periodic table that I use, 1.01. So I calculate that on out. Give me a second. And the total molar mass is 30.08 grams per mole. So that's basically step number 1. Step 2 is now where we use the formula. So I'm going to do percent comp is equal to of a particular element. So I'm going to say the percent of carbon, and what I'm going to do is I'm putting in the total mass of carbon, this is the only mistake people can make, not just the molar mass of carbon, but the total mass. So I'm going to plug in the 2 times 10 to the 12, or 2 times 10 to the 12, sorry, 2 times 12.01, and then I'm going to divide that by the total mass of the compound. And I'm going to multiply that by 100 to get a percentage. So I would do percent carbon is equal to 2 times 12.01. Oh my gosh. 12.01 divided by the total mass of the compound, 30.08 times 100. All right. And with, at least for my class, we will be rounding these down to the 100th place. So we don't really follow, I guess we're sort of following sig figs, but we're always just going to round down to the 100th place, okay, to 2 decimal places. So 2 times 12.01 divided by 30.08, and I get 79, times 100, 79.85%. And that would be the percent of carbon. Now, since there's only 2 elements here, a quick way to figure out the percent hydrogen is just to subtract 100 minus what you just found, because the hydrogen is the rest. So this is coming out to 20.15%. Okay? That's fine. You could do it that way. Okay? Or you could go ahead and go through the whole process again and be like 6 times 1.01 divided by 30.08. Again, we always divide by the same number at this point. Let's see if it comes out to the exact same thing. It could possibly be different by a decimal point. Nope, this came out to 20.15 exactly. All right, but that would be it. So find the molar mass, choose one of the elements, put that like, you know, how the total amount of that element on top over the total mass of the compound on the bottom, and then multiply by 100. And then for the second element, or if there's three, we'll see if we have one like that. Obviously, you're going to have to solve for 2, but then you can subtract 100 from the last one, or 100 minus the percentage of the other 2 to get the final percentage, because again, it should add up to 100. All right, so we'll probably just do 2 more here. Na2SO4. Okay, so we got 3 elements here. So this is going to be 2 times 22.99, that's the sodium, plus 32.07, that's the sulfur, plus 4 times 16, that's the oxygen. Okay? All right, so 2 times 22.99 plus 32.07 plus 4 times 16. The total molar mass of sodium sulfate is 142.05 grams per mole. And it's good if you write it out, because then you can just transfer everything over. So the percent sodium will be the 2 times 22.99 over 142.05 times 100. I'm actually going to write the other ones out to get them all done. Percent of sulfur would be 32.07 divided by 142.05. And the percent of the oxygen will be 4 times 16 over 142.05 times 100. Gotta go back up here, times 100. And there you got all of them. And then you just plug it in. And again, they should add up very, very close to 100. It's okay if you add them up and you get like 99.99 or 98 or 100.01. It's just because you're rounding. So 2 times 22.99 divided by 142.05 times 100. So this would be 32.37. The second one is 22.58. So technically, I could add these 2 up and then subtract it from 100, and that would be my percent oxygen. Or since I already have it here, I can just do it. I'm getting 45.05%. All right, and I can already tell this is going to come out to 100% if I added up all those percentages. Yep, exactly 100. Okay? And again, it should. If you happen, now if you're coming out to like 91% or getting 110%, then you did do something wrong. Okay? The thing you got to be careful with is it's really about getting this initial molar mass, because if you do the molar mass wrong and you have those calculations, you'll still come out to 100. All right, because you're going to be using the wrong calculations that add up to that wrong number. So be careful there. All right, one more. NH3, easy one. So this is going to be 14.01. It is. 14.01 is nitrogen, and then 3 times 1.01 is hydrogen. I'm getting, wait a minute, I did not do that right. 14.01. plus 3 times 1.01, 17.04 grams per mole. And then I would do percent nitrogen equals 14.01 over 17.04 times 100. I get 82.22%. Since this is just 2 elements, I'm going to just do 100. The percent hydrogen is going to equal 100 minus 82.2%, and that is 2%, sorry, 17.78%. And that's it. So that is percent composition. I hope you can do it very, very well, and we'll go from there. Thank you.